Hi all, welcome to Public Cloud Design Tips and Tricks again. Today I will be covering one of the important topic, graph database. It's a part of Azure Cosmos DB. So today I'll be covering the part one of this topic. Yeah. So what we are going to cover in this session is fundamentals and usages of Azure Cosmos DB for Apache Gremlin. That's the graph database. So what is Azure Cosmos DB for Apache Gremlin? Uh, Gremlin is a graph database service and that can be used to store massive graphs with billions of vertices and edges, to query the graphs with milliseconds of latency, and to create an efficient graph structure easily at the end. So these are the three things that Gremlin covers. API for Gremlin is based on Apache Tinkerpop, a graph computing framework basically underneath, and it also supports the Tinkerpop specifications. Okay, so what I have given here is a Microsoft link where you can also check the compatibility of the specification basically. Okay, so please go and have a look. uh, yeah. Now, a little bit of how a RDBMS and graph database looks like on a very high level. So in RDBMS, you have essentially tables, and then within table columns or data types, and then there is a relation between the tables, okay, or between the entity, you can say. So now if you start comparing the graph database, a table represents vertex or set of tables or vertices. Then the columns are properties here in the graph database, and the relations are presented as edge basically. So basically, if you just for an example, like if you go to RDBMS, you can have a person table, a person entity, which will be having different columns like name, age, address, and uh, then there are different relationship of the person with different other properties. So that is how you can define an RDBMS. When it go to the graph database, then how it will be looking like are the vertex person is a vertex here, and it will have different other vertex as well in the bigger landscape. And then the person has properties like person has a name or age. Those are the properties, and then the relationship defines the age basically. Okay, so that is how you can think of a graph database. Now, the API for Gremlin benefits more on a Azure scale is elastically scale. So because it's a Cosmos DB, so Cosmos DB supports horizontal scaling. So underneath graph database also scalable enough in that sense actually, with unlimited size in terms of throughput and storage. A multi-region replication is a fundamental attribute of Azure and again Cosmos DB, so it can replicate geographically to a different region actually, and with that ensures your uh, applications or database is uninterrupted within your applications. Now it has functional query language that store heterogeneous vertices and edges and query them through a familiar Gremlin syntax. So that can be utilized here, and it also provides a set of rich interfaces to implement common graph algorithms. Okay, fully managed because it's a PaaS service, so it's a fully managed. So the developer or the people who are working in Gremlin, they don't need to think about the underlying infrastructure management, software management, upgrades. Those are the common scenario in a PaaS kind of a infrastructure. Yeah, automatic indexing. So by default, Gremlin automatically indexes all properties within the nodes actually. Uh, the nodes are again vertices and also for edges in the graph, and does not expect or require any schema or creation of secondary indices. So that's automatic indexing in Gremlin. Tinkerpop compatibility. That supports, we already discussed, it supports or specification of Tinkerpop. So it will give you a ecosystems of libraries, and that can be easily integrated with the API basically. So um, now tunable consistency, so it has for the queries or read operations within the database, there are five distinct consistency level it supports. Those are strong, bounded, stainless, session, consistent, prefix, and eventual. So these granular, well-defined consistency levels allow you to make perfect trade-offs among consistency, availability, and latency. So these are the benefits of Gremlin API. Now, what kind of scenarios are possible in this graph database? Especially the four. So social network. So basically, you can combine different data within a social network. So basically, different persons you can bring together their interaction pattern. You can analyze and then you can define a personalized experience. Okay. So that is about social network. Then recommendation engine, especially in a retail kind of a scenario, you can very well create a landscape of users, products, interactions, those kind of relationship, and then you can create a sentiments of customers. Okay, you can define it purchasing, browsing, clicks, all the kind of analytics out of it. Geospatial is this is applicable for different industry basically. For example, telecommunication, logistics. Uh, you can create a travel plan, okay, by collecting different kind of informations across a navigation path basically, and then also find a location of interest within the area. You can define a shortest and optimal path between two locations. So that is more, it's a different scenario. And the last one is Internet of Things IoTs basically. So you have different IoT devices, and you can you know place all the devices together within the graph landscape, and then you can build a better understanding of the state of your devices and assets. Okay, so these are the common scenarios that comes in graph database. Now let's little bit discuss the properties of a graph database. So we discussed already on a high level. The first one is vertices or nodes. So vertices denote discrete entities such as person, place, or event. So that is the very fundamental thing of a graph database. Then every nodes or vertices has a relationships. So those are all edges. So relationship to the other entity. For example, a person X knows a person Y knows a person Z. Those kind of a relationship. Okay, so that is the other property that represents with edges. Now a node or a node or the vertices or the vertex can have different properties. So what is a property? Property is nothing but a metadata or the information of the specific vertex. Okay. So there can be any number of properties in either vertices or edges. So for example, in RDBMS, you have many number of columns for a table. Similarly, you can have different property for a vertices or edges also. Okay, and as a whole, they represents an object basically. Okay, they represents an object, and that also can be used to query a specific requirement. Okay, so for example, properties include a vertex that has name and edge or an edge. Okay, which can have a timestamp or a weight. So these are different property attached to either a vertex or a n or an edge. Okay, so that is how you can define. Okay, now there is the fourth one is a level. Okay, so a level can be attached to a edge or a vertex. So it is nothing but uh, a name that is given to a specific vertex or a specific edge. So, for example, you are defining an entity or a vertex called person. So that person can be leveled as person X. So that is how it is. Now the edge is also uh, basically a relationship to the other entity. So person X knows person Y. So the knows can be a level. So that is why a level is a name or the identifier of a vertex or an edge levels can group multiple vertices or edges such that all vertices edges in a group have a certain level. Okay. So that is how you can define the property of a graph database. Now, I have kind of captured an example from Microsoft site. I have followed this particular link where you can see different vertices are mentioned here. So the vertices include people, interest, devices, operating system, etc. So there is a window operating system that is a vertices represents. So basically, a specific device you can see the left hand corner, top corner. There is a device that runs on Windows operating system. So that is a kind of relationship where an device is a vertex, a operating system is a vertex, and then there is a relationship run OS. So this is the edge basically. So you can also see different who uses a device. Okay, what operating system a device uses. Okay, so mm, these are all the element of a graph database. So similarly, the edge, if you can see here, knows, interested, run OS, uses, all those are edges. So you can create different examples of a graph database and you can stitch together the vertices and edges together to create a graph database. So this is what I wanted to say in the session. Is a very fundamental session. In the next session, part two, what we are going to do is I will take you to the Azure portal and then I will start creating a graph database and then we'll try to connect that database from a program, from a Java or Python program. We will try to connect that database and then we can create some properties of a entity. We'll try to create those in the part two of the session. I hope you like it from a fundamental perspective. And that's it for the day. You can always reference to the Microsoft site for Apache Gremlin and you can go through it. Okay. So that's it for today. Thank you and have a good day.